Hey, thanks everyone for joining. And my name is Adam. And in today's session, we will try to go through using HashiCorp for all the secret management that we're going to do in our day to day. Because pretty much when we start working on all the DevOps related tools or automations, there will be a lot of credentials, there'll be a lot of key stores, or there will be a lot of sensitive data that we need to manage on a day-to-day basis, right? And as of now, if you look at DevOps, it's not just about implementing the automation, but also to make sure whatever that we do end to end is also secured. So that's where DevSecOps is kind of getting the priority on all the automations what we do. So from that way, what we have to understand is whether you're using a tool like Jenkins or Ansible or Terraform or Kubernetes or any kind of tool that we are trying to use, we need to make sure that all the credentials or sensitive data that we have been using to connect and execute our pipelines or automation should be secure. So in that way, what are some of the challenges that we start getting into? Because again, when we say a pipeline or an automation, it's not just going to be a single tool or a single server or a single application, right? So there are a lot of things that we have to interconnect. Now, this is when there will be many credentials or sensitive data that we would be using. Now, how do we store all of them in a particular location so that any point of time we need, it should be easy for any new application or a tool to use it. But the point is, where are you going to store? Now, whenever we say storing, we can't just remember the password. Only a single person is responsible for updating all those credentials, right? So we need to have a secure place where we can store all the credentials or the sensitive data that we use in our day-to-day. Now, when we talk about the sensitive data or credentials, it's also necessary that we have a control on who is accessing, from where they are accessing, or what kind of application is accessing. Now, that is where, as we start working on more and more automation, there will be a lot of sensitive data that we handle. And if there is no proper audit on who is going to access, on where it is being controlled, then it's going to be an issue for us in managing the security. Now, another bigger problem that we have is, again, on DevSecOps, the focus, if you have seen, it's not just the application side, but also even for your laptop. What is happening? The organization has certain policies where we have to frequently change the password so that it's not hacked, right? So in that way, for any kind of applications or services or automation, so if you have some sensitive data or some credentials or passwords, it has to be frequently rotated. Rotated means you have to keep changing it. It could be once in a month, or it could be once in a quarter, or depending on your need, you have to keep changing. Okay, so how are you going to change so many passwords, so many credentials within a given short period of time? And not just that, now all the applications or the services which are using those also has to be updated. So this is when, if you're working on an automation team or a DevOps team or an SRE team, it becomes very critical for us to handle all the sensitive data or the credentials in a common place, which could be easily accessed, and we have a proper auditing on who can control and from where we are using it. And also you have the ability to keep rotating the passwords very frequently, and we don't have to take the pain of going to all the applications and keep updating whenever the password changes. So instead, what we need is a solution where all our credentials or the sensitive data are stored in a common location. Rather than we updating these credentials on the application or the services should be able to connect to this centralized location from which we will be authenticating on how the application should use that sensitive data. So that's where in the market, one of the popular tool that we have is HashiCorp's Vault. So HashiCorp's Vault is a completely open source tool for managing any kind of sensitive data, or in simple, it is a secret management tool. So when we say secret management tool, what and all can you handle using HashiCorp? Now HashiCorp can be used to manage any kind of tokens that you want to handle. For example, if you're trying to connect to GitHub or GitLab or some of the tools like let's say JFrog Artifactory or SonarQube. Now instead of using the username and password, you would be using some kind of access token which you need to integrate it with Jenkins or some other tool. So that way you can use HashiCorp Vault to manage all those kind of access tokens. And you can also use the HashiCorp Vault to manage any kind of credentials. That could be like a username and password for a database, or a username and password for a machine, or it could also be a credential that is like your access key and secret key for your AWS, or your login credential for your Azure cloud. So this way, any kind of credentials or passwords that you want, you can store and manage it using Vault. And also, what can be used to handle and manage different types of certificates like SSL certificates or TLS certificates. Now, in additional thing, if you have some kind of encryption keys, you can also use them like PKI keys. And all these are something which you can store in a single place. So that's how Vault or HashiCorp's Vault acts as a secret management tool and a centralized tool in which you can manage all these different types of credentials. Now, how does it work? Now, that's where what I want you to first understand is, so whenever we say HashiCorp Vault, so the thing is, it's a centralized location wherein you can manage different types of credentials. Now, what you also have to know is how these credentials are stored and how is that you are going to integrate different kind of tools and you can retrieve the credentials or the secrets from Vault. So instead of directly you storing all your secrets into the tools, you can integrate your tool with the HashiCorp Vault and you can try to get all those details. Okay. Now, what are the benefits? Maybe before we jump into that, just a quick word. So now when we say HashiCorp Vault features are, it has a better secret management storage. So now instead of storing your storage of secrets in a different location, you can store it in a common location and this can be encrypted. So that's how it is going to be super secure, because even when people say that, you know what, I can store my credentials in a tool like Jenkins or some other tool like Ansible Vault, but still they are not encrypted. Whereas when you store a secret or a sensitive data in your HashiCorp Vault, it can be encrypted. So that is how it gives a super security. And second thing is, you can use HashiCorp Vault to generate dynamic secrets. So what do you mean by dynamic secret? Now, for example, let's say you are using your secret key and access key to connect to AWS. Now, every time if you automate the pipeline of creating something or infra provisioning in AWS or through Terraform or Jenkins, you are going to hard code it, right? So instead of that, what you can do using HashiCorp Vault is you can try to generate a one-time password which will be dynamically generated at the time when you request the HashiCorp Vault to give you a credential, and your tool or application can use that dynamic secret, and as soon as the connection and your automation is completed, you can completely revoke that secret. So that is where it is not going to be the same credentials that you're going to use always. So you can also use Vault completely to create dynamic secrets so that every tool or every user who wants to connect would be getting different passwords dynamically. So that's how you can make sure that your secrets are encrypted. You can generate dynamic secrets, as well as you can also revoke those secrets anytime that you want. Okay, so that's pretty much what I wanted to do in this session. And before we do that, now Vault or the HashiCorp Vault is again a huge tool. So for the purpose of demo, what I'm going to do is I'm going to start it in a simple dev mode, and you can also try it. And later on, when you get hands-on, you can try to set up the Vault in a complete production mode. Now, probably I'll have a part two of the same session wherein we will go deeper into how do we set up HashiCorp for production grade, as well as we'll also see a few more use cases. Okay, so for now, how do you set up Vault quickly on a machine? Now for this, now, I don't want to do anything manually. So because when you say DevOps, even running your commands should be automated. So that's where now, let's say I want to install HashiCorp Vault. Now there are some series of steps and commands I want to run. Now that is technically what we call it as configuring, right? So as soon as you think of configuring something in a machine, the best tool that you should be using in the market is a configuration management tool. Now I preferably use Ansible for configuring any kind of server. And for this, now I have already a playbook that I have now that I can share this later with you guys. So if you look at this code now, okay, so what I'm trying to do, I'm trying to execute the playbook on a local machine, okay, and what we are going to do is install a version called 1.30. Now you can choose any specific version to install. So what this playbook will do, first, again, I'm going to use completely Ubuntu based machine for this demo. So the first task I'm going to do is apt update, okay, and then I'm trying to download the specific version of HashiCorp Vault from this URL, okay. And this is where you can see, based on the version that I pass, I can download a specific version. And where am I downloading? I'm downloading into my temp folder. Okay, so we will do apt update and we will try to download the zip file. And once it is done, I'm going to unzip it. So that is what this task is trying to do. And again, I'm trying to do it directly to user local bin. Okay, so the zip is downloading under temp, whereas I'm extracting it to user local bin. And after that, the command to start the Vault server in a dev mode, okay, because as soon as you extract, you will get the binary of Vault, but you have to start the server, and that's where the last task I've used. Now in this, I'm trying to say Vault server, and I'm starting the server in a mode called dev mode, so that few of the things will be easy for you to practice. And then whenever you're running the Vault server, it's a web application and you want to bind the address through which you will be able to access. Now this is where I'm trying to tell that the Vault server is going to be available on the same machine, so refer the host name of it. Okay, so this will be picking up the IP address of the current machine in which it is running, and Vault server will be running on a port called 8200. Okay, now another thing what you need to know is, when you're starting the server, you always have to give a token. So token is like, again, a credential for you to log into Vault. Okay, now this is what you will be using from now onwards if you want to connect to Vault. So that way, now the token that I'm using for starting the Vault server in my machine is called as Wezva token. Okay, so this acts as my credential to log into Vault server. Okay, so all you have to do now is run this playbook, and the playbook will make sure I have Vault running on that particular machine in a dev mode. Now for this, I've already taken a Ubuntu machine and I've also installed Ansible for the sake of saving time. So I can just go ahead and run it. So again, Let me connect to that machine. Now again, to show you that this is my machine in which I have my Ansible running. All right. So let me connect to this machine. And in this, I have already cloned this project. Like I said, I'll share this project with you guys a little later. And in this, under the Vault folder, I have my script. So I'll just go to this folder, and inside this, I'll go to Vault folder. And this is where I have my setup vault.yaml. Now, however, if you again come back and look into this, all I have to do is execute it. So let's go ahead and run it. Okay, so Ansible playbook, and I'll just go ahead and run this. Now, one thing I forgot to inform you is when you run this command, the vault will be running on foreground. Foreground means as long as this is running, your vault server is also running. So don't stop the playbook. So let it run until your practice. So now vault is running on this machine. Okay. Now to cross check, what I'll do is I'll open another command prompt and I'll go to the same machine. And quick thing is now if Vault is running, you should have the port 8200. So you can see that it is listening. Now, along with it, what I can do is I can take the public DNS, and if I go to 8200, so you should be seeing Vault is up and running. Now it is running in a dev mode, which is the simplest mode. So how do you log in? So you use the default token method, and the token is what I had already mentioned, that the name of the token that I have given is Wezva token. So whatever that you have given, you should be using it over here to sign in. Okay. Now, this is what you have to next understand. Now, Vault is a centralized tool to store all your credentials. Okay. Now, however, in HashiCorp Vault, you have different repositories to store different types of credentials or sensitive data. Okay. See, just like if you go to GitLab or GitHub, you will store all your projects into separate repository, right? Even the same thing if you go to SonarQube or Nexus or JFrog Artifactory, you're going to store all the details into different repositories. The same way, now in HashiCorp Vault, we have something called as secret engine. Okay, so a secret engine is nothing but a repository to store a particular type of sensitive data. Okay, so this is where, depending on what type of data that is the secret you are storing, you need to first enable a secret engine. Now in the default you will not be getting anything, so quickly go to enable new engine. Okay, and over here what you should be seeing is a different types of secret engines available. Okay, now again, as you can see, if you have any credentials related to cloud, you can try to use here. And again, if you have something related to infrastructure or a database, you can store. If you have SSH credentials or Kubernetes, or in general, most of the times you would be using the type KV. So KV is referencing key value pair, right? So most of the type of credentials will be a key name and a value for it. Okay. So now, as I said, first you need to make sure what is the type of secret engine, which refers to the type of secret or sensitive data that you want to store, and based on that you are going to store it. Okay, now first thing what you have to do is you have to enable. Now for the sake of this demo, I'm going to try to store a key value pair, so I'm going to use it as generic KV, which is the first thing. Now come down and go ahead and say next. And again, as I said, a secret engine is going to use to store a particular type of credentials. Now, again, you need to give a name, just like how you give a name to a repository, right? So similar to that, you are going to give a secret engine name. Now, I'll call this as WezvaTech. Okay. And over here, you can see it asks you how many versions of the data that you should be storing. So typically what will happen as you keep adding the data again and again on top of it, you also have a version which this can enable and manage. So if you say, for example, 5, as soon as the 6th time that you update the data, the first value will be getting deleted. So at any time it is going to maintain the last 5 values. So that way for our demo, I'll just say it as 1. Now go ahead and say enable engine. Okay. So now if you go back to the dashboard, you should see there is a new path. Now technically we call it as path in Vault, which is nothing but a secret engine. Now this is of the type KV. Okay, now here you can now store different credentials that you want. Now each set of values that you're going to store is actually what we call it as secret. Okay, so first you need to know what type of secret engine that you are going to store and enable that, and under that you are going to store all the values as set of them. Okay, so that is where each of it is called as secret. So now a secret under the WezvaTech engine is nothing but some values that you want to use, which is of the type key and value. Okay, so what we will do now, to get started with, let us try to see how do we integrate Jenkins with your Vault, so that whatever automation or whatever the pipeline that you want to run from Jenkins can connect to HashiCorp Vault and get those credentials. So instead of you storing the credentials directly into Jenkins, at any time for a pipeline, we can now use Jenkins to connect to HashiCorp Vault and get the values and then run the pipeline. Okay, so the point here is you are not storing the application's credentials into Jenkins directly. So that is what we are going to do. Now, for this, what I want to do is I want to automate a small Docker pipeline in which we will build an image and I will push that image to my Docker Hub. Okay, and in my Docker Hub, so there is a repo called as WezvaTech CI/CD. So what I want to do now is I want to build an image and push into it. Now this is where, if you go back to the basics of Docker, how do you build and push an image? So you should say docker build -t, the name of the image, and then you will have to log in to your Docker registry like Docker Hub, and then you will say docker tag and then docker push. Now this is where, if I have a pipeline, then for that pipeline to do the Docker login and to do the Docker push, I need to give the credentials of my Docker Hub. So instead of hard coding my credentials directly, that is the Docker Hub credentials, into Jenkins, now we will store it in Vault and we will use Jenkins to get that secrets of Docker Hub from Vault. So that is what I'm going to show you the first way on how you can use Jenkins to integrate it with Vault. So for this, now I'll come back to my secret engine called WezvaTech, so which is of the type KV. So click on this, create secret. Okay, and now the path is nothing but the name of the secret or the repository, you can think. So I can call it as Docker Hub. Okay, and what are you going to store? Now in this, every key value will be what exactly is your sensitive data. Now for the Docker Hub, I want to store two things. One is the username and then the password. So now the secret name is Docker Hub, but in that you are storing details as key and a value. So you can store multiple keys and values under one secret. So here I'll give the name, and then I want to add one more key and I will store password. Okay, and here we will put the password. Okay, so what I have done, under the WezvaTech engine of the type KV, I have created a secret and I've stored two key and values, one for username and one for password. Okay, and you can see, so this is where this is a engine under which you have WezvaTech and Docker Hub. Okay, so you can come back and you can see now under WezvaTech there is one secret and it has two key value pairs. Okay, now how does Jenkins integrate with this? Now this is where, if we want Jenkins to connect to Vault, first we have to install a plugin called as HashiCorp Vault plugin, so that we will be able to give all the details to Jenkins. So first go to Jenkins, and in your Jenkins manage plugin, okay, I'll take manage plugin. Okay, so under manage Jenkins, now I'll go to manage plugins. Now I have already installed the plugin, but what you should be doing is you should go to available plugins and search for Vault. Now since I have already installed, it would not be available, but let me show you under my installed plugins. So what you should be installing is this plugin, HashiCorp Vault plugin. You don't have to restart your Jenkins, go ahead and just install. Okay. Now, once the plugin is installed, you will be getting necessary options in which you can tell Jenkins how to connect. Now, that is where now what I want to do is, as I said, I want to create a pipeline in which we will build a Docker image and push to Docker Hub. And for that, we will use the credentials from this Vault secret engine. So let me go ahead and create a new pipeline. So I'll call it as Vault demo, and the type of the pipeline, the job is pipeline. Now over here, I want to say the content. Now before that, what you can do is just save it for a minute, come to the pipeline syntax, and this is where you don't have to even remember anything. So come here, and we need to now choose a step with the help of the plugin what we have installed. So if you have installed that plugin, then if you scroll down, you will be getting an option that is with Vault plugin. Okay, so you can see this. So this is the step that we are going to use. So now watch carefully what I'm trying to do. So here I'm saying use this plugin to connect from Jenkins to Vault and get those credentials. Okay, but now this is where there are two things, if you're not confused. We have Jenkins to connect to Vault and get these values, and with the help of these values, Jenkins will do Docker login and Docker push to Docker Hub. Okay, so that is what we are trying. But before that, your HashiCorp Vault also has a login, and that is where we used a token to connect, right? Now this is where you can also administer your HashiCorp Vault on who should be accessing and who should not be accessing. Okay, so like I said, this is more of a dev mode, so you can take the token and practice. It shouldn't be a problem. So first thing, even before coming to this pipeline, we need to have a credential, right? And that's where I'll go back and we will go to credentials under manage Jenkins. And here what we will do, we will try to add a new credential. Okay, so I will say add credential, and here you can choose the type as vault token credential. So this is how you are first going to tell Jenkins to connect to the vault server using this token. Okay, so come down and give the token. So what is the token? So this is the same thing that we have used here. So copy paste. Where is it? Yeah, here. Okay, and you want to give a name to this. Now for this, I have already a pipeline defined. I'll explain you what is this. So I'll use the name here. So the name of this token, what I want to give is vault cred. Okay, so whenever I refer to vault cred, it knows that there is a token and this is what we are going to use to connect. Okay, so go ahead and create. So you have a new credential called vault credential, which is of the type token. So now come back, and if you just come here, so what is the URL of your vault, which is nothing but this. So take this URL until 8200, give the URL, and then it's asking what credential to use. So now, okay, just refresh once and see. The URL. Now you should get that credential token. Okay. Now, so this way you are telling Jenkins to connect to this vault using the token. But from this, now it has to retrieve the data. So this is where after connecting, every secrets that you are storing has something called as path. So here you can see the path where we have stored the secret is under an engine called WezvaTech, and under that there is something called as Docker Hub. So you are going to give this as the path. Okay, so this is something that you need to first know on how the path will look. So come back here and add a secret, and this is where you are going to say the path. So the path is WezvaTech slash, and you're going to say Docker Hub. So now you go to this URL with this credential, and under that, in this path, it will try to read the key value and give you. Now this is when what you also have to know is how is this value is going to be retrieved. So whatever the key value that Jenkins is going to read from HashiCorp Vault will be returned as a environment variable. Okay, so that is where what key you want to read, and corresponding to that what environment variable in which you want to store. So basically I have two keys, right? Username and password. So what I will do is I will first have one environment variable called username. Again, it's the same name, and the key name is also same. So what I'm trying to do now is I'm trying to read a key called username from vault, that is this, and the value whatever that it is going to retrieve will be stored under a variable called username when you run the pipeline. Okay, so that way you can change this to anything that you want. So I'm just trying to keep both of them same so that it's easy. So whatever the value it is going to retrieve from the vault will be stored as an environment variable when I run my pipeline. Okay, so the value of username will be the value of this key. Same way I'll add one more, and here I will say the same way password, and I want to retrieve this key, that is the password. So I'll go ahead and say password. Okay, so now these two are enough. So come down and just say generate pipeline. Okay, so now you can see this is how you can add this code into your Jenkins pipeline, wherein whenever I run this, and inside this, if I try to use any of the Docker commands, the Jenkins will read the credentials from this, and it will be trying to pass the credentials to your Docker commands. Okay, so now with the help of this, now let us try to define our pipeline. Now that is where I have two things to show you. One is in the same project, I have a sample Docker file. Now there is nothing fancy here. All I have done is take a Ubuntu image and create a dummy file. That's all. Okay. Now, along with it, I also have a Jenkins file. And what is that I'm doing here? If you look, so first, when I run the pipeline, I'm going to check out the pipelines for this code wherever that I have, which is the same project. Okay, and then I'm using the same steps whatever that we have seen here. Okay, now instead of putting this sum block, I'm replacing it with 4 lines. That is nothing but, okay, so now I can copy paste and show you what is it. So let's take this. So this is my code. Okay, now here, if you want, you can replace this, whatever you have obtained. Now it's almost the same what we have just now seen. Okay, right? So the only thing is replace this sum block with this 4 line. And now this is a different URL. So what I'll just do is just take this here and replace with the correct URL. Okay, I don't need this. And what is that I'm doing? So you can see I'm running a stage called Docker demo, in which under the steps you are using this plugin. So now whatever the steps you are going to run within this will be getting this username variable and password variable. Okay, and for that I'm trying to do Docker login, and look at this, and this is where the username and the password is the environment variable which we have asked this plugin to retrieve. Okay, then I'm going ahead and doing a Docker build command and then Docker tag, and here I'm going to do a Docker push of this image to my Docker hub. So for the Docker login and Docker push, the credentials are retrieved from the HashiCorp vault during runtime. So I have not stored the Docker Hub credentials in my Jenkins. Okay, so this is what is the pipeline. So let's try this and see how it is going to work. So now, anyway, let's go back to this job. Okay, so configure. Okay, I'm just going to copy paste this and apply. Now for this, I already have a slave machine added as a part of a group called demo. So that's where when I run, it will just directly connect and run. So let's come back here and just go ahead and execute. So you can see it connected. So it is logging in, it's build, and it is pushing. And where is it pushing? It's pushing to the Docker Hub under my registry called WezvaTech CI/CD without asking credentials. To cross-check, if you now come here and go to this WezvaTech CI/CD repo, you should see there is a new demo which we just pushed a few seconds back. Okay, so this is how. The first method what we saw is if you want to integrate your Jenkins or Jenkins pipeline with Vault, regardless of what commands you are using. So similar to this, you can connect to JFrog Artifactory or for SonarQube or for GitLab. So if you need a credential in your pipeline, so before running it, what you can do is now in Jenkins, make sure you're installing a plugin called as HashiCorp Vault plugin. And then for your pipeline, you need to use this option called as with Vault, and then you try to give the details and automatically it is going to generate the syntax. And then whatever the commands that you want to run with that credentials, you're just going to put it inside it and then run. So this is how Jenkins can connect to Vault during runtime and get the credentials, whatever you need, and it can execute your pipeline. That could be for your build, or it could be for your deployments, or it could be for your testing. Okay. So this is one method. Now let's look at another method where, as I said, you would be using a lot of configuration tools or a tool like Ansible. Now, when we run Ansible, okay, now Ansible also needs some sensitive data, right? Now, in those cases, where are you going to store? So now, if you want Ansible to connect to Vault and get the credentials, similar to what we have just seen for Jenkins. Now, how will Ansible get the data? Okay, so that's where let's just see a small demo on how you can use Ansible to connect to a Vault server, get the credentials, and then you can go ahead and execute your playbook as your choice. Okay, so with this, again, I'll go back. Now, I don't need this for a minute. Okay, and let's come back to my repo. Now again, for the sake of demo, I have another folder called Ansible demo, and I have a small playbook written. So let me just show you what is this going to do. Okay, now it's going to be very straightforward, but a couple of things that you need to know is, again, you want Ansible to connect to your Vault server. Okay, now that is where, since I have my Ansible and Vault server both running on the same machine, I'm going to use the connection as localhost. And for this, I don't have to gather any facts because I'm not going to do anything on the machine, right? So that's the reason I'm disabling gather facts. Connection is local. Now, I have two variables that I have to set. One is what is the token to connect to Vault server, and where is the IP of your particular Vault. Okay, so those are the two things that we are going to tell. Okay, now this is where I've just given a dummy value, but what I'm going to do here now. So in this, I'm not using it anywhere, but I'm just trying to show you how from Ansible you can connect to Vault server, and how is that you can pull data so that the same way you can use it as a variable and you can replace it wherever you want in your Ansible playbook or task reference. Okay, but the only point that I'm trying to show is how do you read it. So for this, now in Ansible, you need to take help of a plugin called lookup, and with the reference of a module called hashi_vault. Okay, so lookup is more of a function which is going to use this module called hashi_vault, and it will help you to connect. And all I'm trying to do is debugging the message, which is nothing but I will try to connect to Vault, and whatever the credentials that you want, I will just print it on the screen just to show you. Okay, so lookup is a function which is going to connect and help you to display that data or retrieve the data. Okay, so for this, you are going to first use this module called hashi_vault, and for that you need to give a couple of information. See, just like in the Jenkins pipeline, we gave where is the URL, what is the token to connect, and then what is the path from which you want to read and what key you want to read. That's exactly what you're also going to give here. Okay, so first I'm trying to tell this is the path from where I want to collect the secret. Okay, now this can change depending on your need. And then to connect to the Vault server, what is the token that you are going to use, and then what is the URL in which your Vault server is running. So you are going to give three details. So where is the server, what is the token used to connect, and from this what is the path in which your secret is available, and it is going to retrieve. So that's where now you can pass your own token as the variable name, because I don't want to hard code. And the same way, if you have any other machine in which your vault server is running, you can simply go ahead and give the IP address of that, and it will try to connect. Okay, so right now when I run my playbook, I'm going to pass this token and the vault IP during runtime, so that when you are running, you change it to your values. Now, before that, for this demo, I want to create another key value, and we can ask Ansible to read it. So let's go back to our same WezvaTech engine again. You can go to this. So I don't have to create the engine again, because I already have an engine for key value pair. The only thing is some data. So I will create a secret. Now here in my playbook, I've already predefined saying I want to read something called as Ansible demo. So I'm just going to give this. Okay, so the path name is Ansible demo. Okay, and what data you want. Now I'm just going to put some dummy data. Okay, so I'll just say my name, and I'm going to give my name. Okay, so add. All right, so I'm just going to say it's not a secret, but just I'm trying to show you some dummy value. What is my arc? I'll put some value. Okay, now you want to see what are those values, you can just click it here and see. So now I'm creating two keys and value. One is my name, Adam, and another one is my arc and WezvaTech. So go ahead and save. So now you want Ansible to connect to Vault and read this secret in which you have two key and value, right? Now, there's a small difference when you use Ansible is when we were using Jenkins, we gave the path directly as WezvaTech and Docker Hub, right? Whereas when it comes to Ansible, what you have to do is you will not be giving directly as WezvaTech slash Ansible demo. Instead, you have to say WezvaTech slash data slash Ansible demo. So that is your secret engine slash data and slash the name of your secret in which you have the key and the value. Okay. So this way, if I run this playbook, Ansible will connect to Vault and it will retrieve this data. And since I'm using the debug module, it is going to display. So this is how, with the help of hashi_vault module and lookup function, we are going to retrieve. Okay. But when you are trying to use the hashi_vault module, now we know that Ansible runs completely on Python and your modules are all Python based. So there is another dependency on a module. Like if you want to run AWS things, you need Boto library or module. Same way, for running HashiVault, you need to have another module of or a library of Python called Havoc. Okay, so first make sure you install that and then run. So that's where in my playbook, I'm making sure first on whatever machine you have the playbook running, install Havoc and then use the lookup function to connect and run. Now all of them, I'm going to run it in my local host. All right. So how am I going to run my playbook? So once again, I'll go back to my project, and this is where the command that I'm going to run is going to look something like this. Okay, so what I'm going to do here is this. So I'm going to now call Ansible playbook and the name of my playbook, and see here I'm passing the environment variable called my token and what is the value. Now it's the same value that I'm running my dev server, that is the vault, and then I'm also saying my vault IP. Now for that, since it is running on the local machine, I'm just using a command called hostname-i and I'm printing only the first value, which is the IP address. So This is nothing but my vault IP will take my IP address of my current machine and it will be replacing it accordingly in I'm at the AWS gets disconnected frequently. All right, let's connect. I'll go to the same folder of the project and Ansible demo. Now this is where we have our playbook. So now I'm going to run this. So in your case, what you are going to do is replace the value of my token with your token and replace the value of my vault IP with your IP address in which the vault server is running. Okay. So let me go ahead and run. So we are running it on the local host and we are making sure this Havoc library is installed using PIP. And you can see that the task, what we have used is a message task. So it will just print it on the screen. And what it has done, it was able to retrieve the secret from Vault and it is just giving it to you directly. So the same way like Jenkins, you can now use this variable and refer it anywhere in your playbook or a task so that when you run Ansible, Ansible will connect to Vault and get the values. So you don't have to hard code any credentials or any sensitive data in your playbook. Okay, so this is how you can integrate your Ansible playbooks with Vault to get the credentials during runtime. Okay, now another interesting topic that I want to talk about is dynamic secret. Now, in the beginning, I told you one of the key feature of HashiCorp Vault is dynamic secret. Now, maybe this is also something for your interviews or for your upcoming projects. So, what is dynamic secret? Now, for this, let me take a reference of cloud and Terraform and correlate. So now, let's say you are going to use AWS as your cloud platform. Now, to automate the infrastructure, what you will do, you will be using CloudFormation or preferably Terraform so that you will define Terraform code or Terraform modules and you will run. So Terraform will connect to AWS and it will provision everything that you need. Okay, absolutely fine. But now for Terraform to connect to AWS, you will be using a provider block, and along with the provider block, you need to give credentials. Now that's where, so far, what we have learned is Terraform to connect to AWS, it will need the same access key and secret key. Now you can set it through an environment variable, that is one method, or you will put it under a file called .aws credentials, and from that you can take it, right? For example, come here and I'll show you. Now, for the sake of benefit, on the demo, I've also installed Terraform on the same machine what I am running. Okay, so I have Ansible also on the same machine, and I also have Terraform on the same machine. Okay, now this is where, as I said, either you must have some environment variable in which you have everything set. So you can see I can have some environment variable like this. So access key, and again, if I go up, you would see my secret key also available. So I can see you can store like this, and if you run Terraform, Terraform can access your AWS through this. Or another way is, as whatever user you are running Terraform, under the home directory, you should see a file called credentials. Okay, And in this file, you will be giving the profile and the details of that. So for example, just to quickly show you, so I can have different profiles and credentials added to it. Now this is where in both these cases, you are hard coding, right? That is first problem. The second problem is every time different users wants to run, all of them are going to take the same credential. Now this is when during runtime, rather than having hard-coded value, now I can replace this and I can put it in Vault. Okay, now I can do that. But what will be the difference? Now let's take this Jenkins example and Docker or Ansible. We had the same username, password, or whatever the credentials which is available in Vault. It's not at all changing, right? Now, instead of the same way, like what you can do is you can add those access key and secret key. And if you ask Terraform to connect to Vault, it will use the same credentials again and again. Now, typically for a production environment, in DevSecOps, this is not the right way to do as we move forward. So what we should do is we should be generating a secret dynamically whenever we connect to Vault. And that also, that secret should be available only for certain time. That means now consider this way. If anyone in my team wants to run Terraform, I can automate it in such a way that if I connect to Terraform and from Terraform to Vault, Terraform will get a dynamic secret which is available for only one time or for the limited time how much you tell. And after that, the password will not be available. So even if someone tries to hack with that, the password will not be available for a long time, right? So that way, every user, when they connect using Terraform to Vault, you are not going to get a static address or you're not going to get a static credential. Instead, what you're going to get is a dynamic credentials. So the logic what I'm trying to tell is every time now when we connect Terraform using Vault, you will be getting a dynamic AWS credential. So it is not going to be the same credential. So this way, your connectivity between Terraform and your cloud infra will always be secure. Okay. Now, this is the advanced way of securing your infra in many cases. So that now, if you understand, I don't want my Terraform to always use one AWS credential. So whenever I run with the help of Vault, we will be able to generate dynamic credential. Okay, so what is happening now? Terraform will connect to Vault and Vault will give a dynamic access key and secret key which Terraform will use to connect to AWS. And when you are setting up Terraform, you can also set up in such a way the dynamic secret can be used only for one time or for a certain time, and you can revoke, so that if anyone else tries to use, or even if you use Terraform to connect to AWS again, the same credentials will not be valid. So that way, dynamic secrets are generated on the spot when you connect to Vault, and you can use that credential something like a one-time activity only. So that is how your infra provisioning will be way too secure. Okay, so how do we achieve it? Now this is where for us to generate dynamic secrets. Now since I'm going to show you the example of AWS, so first thing you have to do is enable the cloud based secret engine, that is AWS type. Okay, so once you generate, now there are a bunch of things you have to do. Maybe I'll just tell you what we have to do. So first you have to enable the secret engine of the AWS type. Okay, and then you need to create something called as a profile, because this is where the basics what we saw is, okay, you connect to Vault and get the data, but you can also secure your Vault in such a way who should be accessing, who should not be accessing. So that is when, if Terraform or anyone else is trying to connect to Vault, and in the Vault to this particular secret engine, you can typically tell who is allowed to access and who is not allowed to access. So that's where we will create the profile. And the third thing is we will input the AWS credentials. Okay. So this is for us to enable the secret engine. So now what will happen? We can ask Terraform with the help of Vault to connect to the AWS secret engine, and it can use this profile and generate a dynamic secret. Okay, so that's where, let me go back to my code here. Now I don't want to do anything manually, because this is where anything on AWS I want to do, that is I want to create a profile as well as I want to create an engine in Vault. Rather than doing manually, we can think of provisioning everything through Terraform. Okay, and for this, come back. Now I already have a code written. Okay, so first thing is I'm going to set up this, and this is where if you look at this code, so this is a code where what I'm trying to do first is enable my Vault secret engine for AWS. And this is when the provider is not AWS, because first I want to go to Vault and enable the AWS secret engine. And in that, I want to store the credentials of AWS. So that is like your root credentials for the beginning. Okay. So that is what you're going to do. And for that, I'm going to use Vault as the provider, and then I'm trying to say the resource block as Vault. So what will happen now? We will be able to connect to the Vault, and we are going to enable a secret engine. And in that, we are going to store the access key and secret key. Now, this is where you might be confused. Okay, where are we telling where is the Vault server IP address? Because in Ansible and Jenkins, we were clearly telling, but here in the provider, there is nothing given, right? So I'll show you from where the details are getting pulled in. Okay. And same way, now I'm telling that in AWS or in the Vault under the secret AWS engine, you are going to store the credentials. Once again, where is the values coming from? So you can see I'm putting it as a variable. So whatever the values that I pass to these variables will be taken as the secret key and access key, and under the AWS engine, it will be storing it. Again, the question, who is going to pass this value? Okay, so I'll show you those two data. Okay, just remember. So you need to know from where are you getting the IP address of Vault, and you also need to know from where are we going to pass the variable values of the access key and secret key. Okay, now, okay, so that's the first thing. The second thing over here is, now once you enable the secret engine of the type AWS, what we are going to do is we are going to create a policy. Now this is where it's a AWS IAM user policy and a role called demo role that we will be creating. Now for that, for this demo sake, I'm saying allow everything. Okay, so that when you run, you should be able to access it. So that's how you are trying to enable the AWS engine in Vault, and then in the Vault you are creating a role for AWS which will allow. So now what will happen when Terraform is going to connect to Vault, and when it is trying to read this secret engine, this role will be applicable, and with the help of this, Vault will not give the credentials what you are storing here. Instead, it is going to generate a dynamic secret and return. Okay, so this code is only for enabling the secret engine of Vault AWS type and storing the root credentials. And then we will see how to generate that dynamic secret secondly. Okay, so remember, this is for enabling the secret engine in Vault and storing your root key. Okay, and setting up the policy. And this is just to show you what is the return value and the name of the role. And this is where, before we run this code, Now I told you that I need to get the IP address and the access and secret key. So that's where, to make it simple and to make it everything automated, I have a shell script that I have written. Okay. So what is the shell script going to do? So now when you run this provider block, if you do not tell where is the IP address of Vault server, generally Terraform will check for a variable called vault_address. And that is where I'm trying to say that it is available on the same machine. Now you can replace this with your address or IP address of your vault. So now by referring to this variable, this provider block will know, okay, this is the location of my IP, or this is the location of my vault server. And then I'm also giving another variable called vault token, and it is the same token that we have initiated our dev server. So with the help of these two variables, first Terraform will connect to Vault, and then it will try to enable the secret engine. Now, in that, it needs to store your access key and secret key. Now that I'm passing it through a variable here. But who is setting the value for this variable? And that also I want to do dynamically. So this is where the concept that I'm going to do is either you set it separately. If not, in this machine where I'm running Terraform, you can see I've already stored the credentials into this file, right? That AWS credential file, that's a .aws credentials, right? So what I'm trying to do, I'm trying to read from that file, and I'm setting up an environment variable or a Terraform variable during the runtime. So that's where you can see now, before you run the Terraform commands, you will have the vault address, vault token, and a variable called access key and a variable called secret key. And once all these things are there, it will get substituted over here. And then rather than me sitting and doing init, plan and approve, all I'm trying to say is put this in the script. So now when I run the script, what it will do, it will take all these values and it will go ahead and enable the engine, and then add the values of your access key and secret key with the variable, and it is going to enable a role. So this you are going to use from other modules or Terraform code whenever you want to generate a dynamic secret. So this is like a setting up of your secret engine to enable dynamic secret. Okay, so let's go back to my project. Again, I'll go to this folder called cred setup. Now, I just want to show you so that this is also a project where I don't want you to sit and do anything manually. Okay, now this is my code and I don't want to do anything manually. So just go ahead and execute TF workflow. So what this will do, this will set up all the variables needed and it's going to call your Terraform. Now, if you want, you can run it from Jenkins also. Okay, but anyway, so it has created and it has also defined a role called demo role. Okay, so now come back to your Vault server and refresh this. You see there is a secret engine of the type AWS. The name is also AWS, and under that you have a role, and this role has the same features what we have already given. Okay, now anytime if you see, if I come and click on generate, it will generate a dynamic secret which you can tell how long it should be, whether it should be like a one-time access like a OTP, and revoke it. But I don't want to do that manually. So now what we will do, you can write your new Terraform code, or you can now give this to all your engineers and you can tell, hey, from now onwards you are going to use Terraform can connect to AWS, use this particular role which is available in the vault, which will generate a dynamic secret whenever you connect to it, and that will be revoked immediately. Okay, and that's when I have another sample code on how to generate this secret. Okay, so once again I have the code. So what is that I'm doing? So once again I'm trying to connect to Vault. So in the same way, I would like to first set my vault server and token, and then I'm trying to pass two variables. One is the backend and the role name. So this is something which we have obtained here. Okay, and then what I'm going to do is using a data block. So this is where in Terraform, data block will just retrieve, right? So first what you are doing, you are connecting to the vault with the help of this, and you are retrieving. Now this is where you will be generating the dynamic secret. So whenever you say this data block, it will come here and it will connect to this, and it will generate and it will return a dynamic secret. So this is not the first credential what you stored. It is going to generate a dynamic secret, that is dynamic access key and secret key. Okay, and that will be returned here. So that's the first thing. And then now if you now come back and look into this, now this is where we are telling go to AWS, because so far who is generating the dynamic credential? Vault is generating with the help of the role what you have. So far you are not connecting to AWS. Vault is going to connect to AWS and generate the credential, and that will retrieve here, and then you are giving the provider block. So in the provider block, you can see I'm mentioning my access key and secret key is obtained from this data block. Okay, so what is happening during runtime? The data block will generate dynamic secret and it will be substituted, and now when Terraform is connecting to AWS, it will use this dynamic secret, and as soon as your Terraform code is completed, this will be revoked. Okay, and finally, just to show you the example on how this credential is used, I'm just creating a dummy user called Adam with the help of this dynamic credential. Now as soon as this has been executed, the credentials will be revoked. So this is how in your code all you are going to refer is where is your vault, okay, and in the vault where is your secret engine from which you want to retrieve the data, and use that as your content for your connection, that is access key and secret key in your AWS. Okay, so I have not coded. So suppose assume this is your actual code to provision and you don't have anything in terms of hard coding the value. Okay, and once again, to run this, before you run, you need Terraform to connect to Vault server to retrieve data. So for that, you will use the same shell script, or similar to that what I've done. I'm using a shell script to set the Vault address, Vault token, and the same way. So now what will happen again, I'll repeat. We will connect to Vault. We will go to this secret engine and we will generate a dynamic secret with the help of this data block, because data block is only for reading, but while it is reading from Vault, it will generate. Now Vault will generate and give it, and that we will substitute here, and further on whatever the resource block you're going to use, we will be using the dynamic credential. Okay, and that's when it again disconnected. Just give me 1 minute. All right, let's connect and execute it. I'll go to the project folder, and in this I'll go to demo. And now, again, I don't want to run the flow, so instead I have my shell script for this. It will set the necessary variables, and I'm going to generate the dynamic secret. And once it is done, we will use that to connect to AWS, okay, and create a dummy user. Yeah, now why is it taking time? Because first, when the data block is connecting, the vault is generating a dynamic secret. So that's where you see that it's taking some time. And once it is done, then it will go ahead and start executing your workflow, and it will create whatever the resources that you want. Okay, there you go. Okay, so it has generated the dynamic secret on the background, and it is now saying, okay, with the help of that dynamic secret, you are going to create a new user called Adam WezvaTech. Okay, so that's what it is trying to apply. Yeah, it should take a couple of seconds, but anyway, so you can see now it has taken the dynamic credential. Now to cross check, so sure. So this is the user, what it has created, and that's Adam WezvaTech. Once again, now every time it's slow because it's trying to use the dynamic secrets to connect. You can see. So this is the data block, okay, and the role name, and this is the user. So if you go to IAM role, you should see there's a new user, but again, to connect, what we have used is dynamic secret. All right, so this is the one. All right, so this way, now as you move forward, one of the key feature on why Vault is popular or why you should consider Vault is you are going to use Vault to store as a centralized secret management tool. Plus, you can automatically rotate your passwords in it, and you don't want to update your tools. You just have to connect your applications to Vault through some APIs like what we have seen, so that the tool can read from, or the app can read from Vault. And finally, instead of using the static credentials, you can use Vault to generate dynamic credentials. Okay. Now, with that, as I said, this is a part one. So in the next session, we'll try to go through how do we really set up a production grade Vault, and the other important factor of using Vault is in your deployments, wherein we will see how do we integrate Vault with Kubernetes. Okay. So until then, thanks for joining, and my name is Adam.